Hello everyone. I think in the previous video I have shown you how to do the post layout simulation, pre-layout simulation, as well as the post layout simulation of common drain amplifier, which would act like a source follower, right? We have checked all the simulation results. Now in this video we will see how to do the pre-layout simulation for a differential amplifier, where the difference of two inputs will be amplified to a certain range, right? So for that, first we have to create a new file, cell view, right? I'll go to file, so new cell view. Here I'll give the name as differential amplifier underscore schematic. Okay, so I'll just click OK. Now the schematic window will appear. Here I need to create the schematic circuit. So how to do that? First I need a PMOS, so two PMOS components. So how to add the instances? Click I, go to browse. Here under GPDK45 I need PMOS version 1, right? I'll take here, so I place one PMOS, right? Now again I'll come back to add instance. Here I need again one more PMOS. I need one more PMOS. Now I need one more PMOS, so that direction is supposed to be the reverse side. For the connection purpose I'll just take sideways, so like this. Fine. So I'll place one more PMOS here, right? So next I need 4 NMOS circuit. Fine, just like this. Yeah, I'll go to add instance. I'll browse, I'll select NMOS. Fine. So NMOS I need, so just close this. I'll take NMOS at this point. Okay, in the same way again add instance, I need one more NMOS, so I'll just take sideways. I'll connect here, right? Again I need two NMOS, so which are supposed to be connected here. I'll just rotate it, so but I need upside down. So make sure the source connection should be proper, otherwise it will give you the errors. Fine, make sure this source connection is proper. Okay, fine. Again I need one more, so I'll take sideways, so I'll just place here, so I'll have the connection at this point for IDC connection, right? Now so the connection has to be made. So how do we do that? I need pins first. For differential amplifier I need total 6 pins. So in that 4 are input pins, or 5 are input pins, and 1 is output pin. So we shall see that. Go to add pin. Here I need VDD, so VSS, then I need V1. So first we'll give the VDD and VSS first. So add. So I need VDD here. Fine. Then I need VSS. So I need VSS at this point. I'll rotate here. I'll place it. Then once it is done, so then I need V1 and V2, right? So add pin V1 and add pin V2. It's also input pin, so I'll place it here. Then I need IDC, which is also an input pin. Okay, so add pin, so IDC, it's also an input pin. Okay, so I'll rotate this, I'll place it here. Fine. So so that I need to be placed. Now I left with one pin, that is output pin, so I'll add V out, which is basically an output pin. Okay, so just hide this and place it here. Now the connection has to be made. I'll take wire, so W is a shortcut. First, source and source has to be source and source has to be connected, right? Then that has to be connected to VDD, right? So then gate and gate is short circuited, right? Then the drain and drain are connected, and we have a substrate connection, right? So then we need to give the substrate connection, right? So for that, so then it has to be connected like this, right? So then, so V out connection, so we'll take from here, right? So then these two pins are connected, right? So then we need to give the gate of NMOS 1 is connected to V in, and gate of NMOS 2 is connected to V2, right? So then we have to give the connection to NMOS, so we have given, right? So then, so gate of this NMOS 1 and NMOS 1 are interconnected, right? So and its source is connected to so VSS, right? Sorry, the source of NMOS, so this is actually, and this is connected to VMOS. Again IDC is connected to drain of NMOS 1, and we have to give the substrate connection, so this is connected to VSS, and this substrate is also connected to VSS, and again these two NMOS substrate connection has to be given, so I'll take it here and I'll give it to this. Now I think we have given all the connections, right? So make sure the source and properly placed, otherwise we will get the error, and make sure this substrate connection is given to VSS. Fine, if that's case, the circuit is completed, so just click save. Now we have to create the symbol first for the same circuit, right? So how to do that? So we have to go to create, so from cell view we have to go to from cell view. Here let it be the same name, I want to give the symbol, just click OK. Now it is asking how do you want to place your pins, right? So what I do is I'll keep the VNN, V1, V2 and IDC on the input side, and VDD and VSS on top and bottom, okay, just for the connection purpose. So I'll have VDC here and I'll have VSS on the bottom, okay, fine. Yeah, sorry. Now I have given the pin connection, I'll just click OK. Now the pin configuration has been given properly, fine. So VDC, IDC, V1, V2 and IDC has been given. Now once we have generated the symbol for the same, so we shall save this and we'll close this. Now what we have to do, we have to verify its simulation results, right? So how to do that? So again same thing, so we have to go for to create a new file for a test bench, right? I'll go to file, create new file. For schematic I'll give it as test bench. Okay, I'll just click OK. Now I have created a test bench circuit. So here we have to create the test bench circuit. So how do we do that? Add instance, go to browse. You have to search for the symbol that you have created, right? It is in the test library in that differential amplifier schematic. The symbol is there. I'll just close this and I'll place it here, right? So now the IDC and VDC, sorry, the amplifier circuit is placed, or the schematic symbol is placed. Now we have to give the certain settings, right, for giving the analog components by connecting the analog components. So how do we do that? So first I have to give the VDD, right, VDC. So I'll go to add instance, I'll browse. In the browse I have to search for analog lib. In the analog lib I need first VDC, right? So symbol, just close it here. So in the instance I need to give the DC voltage, right? So let it be 2.5 volt. Fine, I'll just close here and I'll just rotate this. So I'll just place it here, right? Now I need to give the VDC for VSS. So again add instance, VDC is already selected. I'll give DC voltage, let it be around minus 1.1 volt, right? Or you can also give 2.5 volt, so less voltage is better, right? So hide this and place it here. Now I need to give the IDC pen, right? So how do we do that? So add instance, search for IDC, right? Symbol is already there, symbol selected. Just close this. DC current we have to give DC current, let it be 30 microamperes. Micro is here U. Fine, so just hide this and place it here. Fine, now we have to give V1 and V2, right? So V2 let it be directly a 0. So I'll take add pin. First I need to add the V out pin, so I'll add V out, the output pin, right? Then V out, let it be the 0, so I'll add ground directly. So P, add instance, so I'll select ground, right? So one is here and one is to VDC, then one is for V2. Fine, and we left with V1, so we shall give the V1 input. So we have to browse, take V sign, right? So V sign symbol. So here you have to give the input as well as output voltage. So DC voltage let it be same, AC voltage let it be 1 volt, then the amplitude let it be 5 milli, right? The frequency again let it be 1 kilohertz, and same thing what we have given previously, right? Just hide this, I'll place it at V1. Okay, now you can directly take it here. Now I need one more pin for grounding purpose here, so I'll add instance, I'll go back, I'll select ground, GND, so hide this and place it here. Now I need to give the connection for all the components, so select wire W, so W, take a connection, so VSS, V out, V1, ground connection. Then you have to give the IDC also, so you can just directly take it here, right? And this is connected to IDC, right? Then output is connected across V out. Okay, so now we have successfully created the test bench for differential amplifier, right? If you observe here, it's not given connection properly. Yeah, now we have successfully created the amplifier circuit. Now what we have to do, we have to verify its analysis for different analysis, right? How do we do that? So basically just save this, then we'll go to launch, select ADEL, right? Select yes. In ADEL, so what we have to do, so the schematic parameters, so go to analysis, choose analysis. First we'll select transient, the input, so we'll select, so stop time, let it be some 5 millisecond, 5 millisecond, let it be the moderate, so I'll select apply, right? So then under DC, save DC operating point, select operate on the top, so select V in DC voltage, click OK. Fine. So now it is selected. Start and stop range it is asking, let it be from -5 to 5, right? Let it be automatic. Click apply. Now we have selected the DC analysis. Now next is AC analysis. So let it be the frequency range, same thing from 100 to 150 megahertz, let it be the same. Sweep type, let it be logarithmic, 20 decade per 20 decades, right? Now click apply. Now all the parameters are selected. Now what we have to do, we have to plot the output. So how do we do that? Go to output, to be plotted, select on the design, right? I'll select this. Now what I want, I need V1, V2 and V out, right? Because differential amplifier will take the difference of these two input V1 minus V2, then that will be amplified at the output side, right? So that's why I have selected this. Okay, so now I'll come back to ADE1. So I have selected net 3 ground and V out, right? Basically ground means it is 0 only. You can select it or unselect it, it will not make a difference. So for your understanding I have given like this. Okay, so next, what is the next step? Just run for simulation. Okay, now you can see the simulation results, right? We'll separate this, right? Now you can see the output difference, right? So this is the input signal from 5 volt 5 millivolt peak to peak. That means if you take the peak to peak voltage, it is 10 millivolts. V1 is 10 millivolts and V2 is 0, right? So that means V1 minus V2 means I'll get 10 millivolts, right? So that is the difference output, right? Because it's a differential amplifier, V1 minus V2 here we are getting is 10 millivolts, right? Because the same thing we have given here also, right? If you check here, see, this is 10 millivolts peak to peak and V2 is 0. V1 minus V2 means 10 millivolts peak to peak input signal, right? So how much output voltage we are getting? If you check here, it is 1.75. I'll just take the calculator. So it is 1.8745. So 1.8745 minus, if you take here 1.6816, 1.6816, right? If you check here, you are getting around 20 millivolts, right? Sorry, yeah. So you're getting, so 0.75 means you're getting in terms of voltage right? So 0.867 volts, sorry, 0.1929 volts you're getting. So in terms of millivolts, you're getting 192 millivolts, right? So how much you're getting means around 19.7 amplification you're getting. So gain is around 19.7, right? You can check here also, same thing you can check from here also. See, the gain is around 19.42, so that much voltage, sorry, amplification you're getting. So this is how a differential amplifier would works, right? So from a differential voltage would be amplified to a certain range, right? That is around 19.42, right? How to save this now? Just go to print. So go to your test folder. Here save this file as differential amplifier pre-layout simulation, right? Just save this, save and print. Okay, so this is the pre-layout simulation of results, right? So you have to know, so we are getting properly, so difference voltage is amplified to up to 19%, 19.7. Okay, so thank you.